right, guys, hello, and welcome to our one video that's going to cover 3 lessons. Are you ready for this? So we're doing 13B, 14B, and 15B today. It's all the same idea, line of best fit. So what you need to fill in is that bivariate data is data for 2 variables. Like a bicycle has 2 wheels, this is 2 variables. Usually the data is related, so that's an X and a Y. All right, a scatter plot is a coordinate graph of scattered data points. So this is what real data would look like. If we were actually measuring things, it wouldn't come out in a nice clean-cut line. It would generally come out like this. And so what we need to make is a trend line. So please write down that a good trend line, it's called a line of best fit or a trend line, goes through the middle of all the points. But it's just one line. So we're not playing dot to dot. We're just going to take our ruler and we're going to try to draw a line through the middle. And so if we're looking at this one, we look for like where all the middle of the points go and we draw one line that's pretty much going through all of them. So what I just drew would be a good trend line. This one is generally going up. So that's called a positive correlation. Positive correlation, because it's generally going up. For this one, they're generally going down. And so to draw a trend line, I would do this. And I would try to make it go through the y-axis and through the middle of most of the points. Again, you're just drawing one line that pretty much goes through all the points. Notice on this one, they go down and then back up, so there would be no correlation here. In other words, they're not all going in one direction. And I didn't write this one in, but this one is a negative correlation because they're all generally going down. And so we look for where most of the points are going. And if there's some, like here, we would draw a line right about there. That's why that's circled. That's the majority of the points. So this one is generally going up. That's a positive correlation. Now, there are things called outliers, which are points that are like random, that are way far away from the rest of them. So, for example, if we had this positive correlation of points, and then we had a random one over here, that would be called the outlier. All right, but remember, a good trend line goes through the middle of all the points, and it is one line. All right, so on the next ones, they've drawn in the line for us. So there's our good trend line, and we can make our equation based off of that line. So we don't have to go point by point. We can go based off of the line that pretty much goes through all of them. This week, we're going to be looking at real data, so you can see what it's like to actually measure things and put the results on a graph. It's not always pretty. And so we put points on there wherever they were, and then we draw the line that goes pretty much through all of them. Once we have this line, then we can make an equation. Look for the y-intercept. On this case, looks like they went by 5s. Let's see, 5, 10, 15, 20. Now they went by 5, so the y-intercept would be 0, 5. And the slope, so it looks like it goes from there. Another good point that looks like it would be on this line is right there. So from there to there, it goes from 5 to 15, so it actually goes up 5, 10, goes up 10, over, and what are they going by here? It looks like they went by 50s, 50, 100, 150, 200. So 50, 100, so that means it went up 10 over 100, or if we reduce that, it would be 1 over 10. Well, what is this talking about? Maximum life in years and the brain weight? That's a weird thing. So apparently the heavier your brain is, the longer you live. That's a weird thing to associate. Apparently that's in animals. Weird. Who measured that? Really? Okay, well, we have our y-intercept. We see where it starts. So apparently when you weigh nothing, you still have a brain weight or a maximum life of 5 years. So we're going to go over here and we are going to write this equation. So to make a linear model for this, remember it's y equals mx plus b. So this one would be y equals 1/10 x plus 5. So there is our equation that would match the trend line going through most of those points. Now it says predict how the maximum life expectancy for an animal that has a brain that weighs 300 grams. So we're going to use the graph here and we're going to estimate. So a brain weight of 300 grams looks like it would hit right there. And so that life expectancy would be about 35 years. Now we could also use our equation here. We know that y is the maximum life and x is the brain weight, and so we would plug in the brain weight for x. So that would be 1/10. 1/10 times 300 plus that 5. A tenth of 300 is 30 plus 5, and we get 35. Now, what about the opposite of that? Predict the weight of an animal's brain whose life expectancy is 60 years. So we can use the graph, but the graph only goes up to 55. And so we could estimate that it would probably hit this graph right around here, which is about 550 or 600. But since we can't see it on the graph, we can plug in the years for y. And so we could do 60 equals a tenth of something plus 5. If we subtract the 5, then we would get 55 equals 1/10 of something. And a tenth of something, to figure that out, we'd multiply by 10. And we'd get 550 equals x. So we would expect something that is expected to live 60 years would have a brain weight of 550 grams. So that's how we use the trend line. Let's look at a couple other ones. This one is looking at vehicle sales in millions over the number of years. So it looks like as years go on, the number of sales increases. Here the y-intercept looks like it's at a fractional point. So I would say that's in between 0.5 and 1. Let's call that 0.75. I like to work with decimals rather than fractions, so that's 0.75. Let's make that a point since it's asking for the y-intercept. 0.75 would be the y-intercept. And for the slope, let's use 1, 1. And another good one is right here at 6, 2.5. So let's see how much it goes up. So it goes up 0.5, 1, 1.5, up 1.5 over, what's this going by? Ones. So let's go over 1, 2, 3, 4, 5 over 5. And so if I have 1.5 over 5, that's the same thing as saying 3 over 10. And so our slope could be written as 3 over 10. So our linear model would just be y equals 3/10 x plus 0.75. Estimate when the vehicle sales were 2,500,000. Estimate when those vehicle sales were 2.5 million. 2.5 million went with 6 years. So we can use the graph for that. What vehicle sales will be in 15 years? So in 15 years, years is x. All right, so that's the x value. I took that off the graph. And so we would say y equals 3/10 of 15 plus 0.75. And remember, we can cross reduce here. That would be 2, that would be 3. And so we'd get 9/2 plus 0.75. Well, 9/2 is not very pretty. And so let's change that to a decimal. We could take, let's see, 4 2s out of 9 and have 1 left over. So that'd be 4.5. So let's change that to 4.5. And remember, you could always use your calculator for that. 4.5 plus 0.75 is 5.25, and that would be $1 million in sales. So after 15 years, we would expect $5.25 million worth of sales. All right, let's make another equation because that's really what we're going to have to do. But this time they didn't give us our trend line. So let's take our ruler. Let's go ahead and line it up here. We want to go through the majority of the points. So let's see, right about there looks like it would work. Line up your ruler, draw your line. That looks like it goes through basically the middle of all those points. And it happened to hit at a nice spot here on the y-axis. So that's hitting, looks like it's going by 5. So that's hitting at 0.35. So there's one good point. Let's see if our line hit at any other good points. Let's see, another good point looks like it might be right about there. And it's okay to estimate a little bit with trend lines. So that tells me if this is a good point right here and this is a good point here, it's going down 5. So down 5 over, what's one of these units? 12. All right, so there's our slope. So our linear model would be y equals -5/12 x plus 35. All right, we're going to skip those last questions because what I really want you able to do is writing equations for this. So let's look at lesson 14b. And here's our data. So they didn't give us a whole lot of data, but we can already see that it's starting on the y-axis there, and it's kind of going in a downward slope. So go ahead and draw that trend line on just like that. And so remember before we looked at the y-intercept and then we looked at where it went from there. There's 2 good points. So let's write them here. The y-intercept. Y-intercept looks like it's at 0. I would say that's halfway between 90 and 100, so 0.95. looks like a good spot there. And then our slope. From there, it goes down, let's see, 5, 10, 15, down 15 over, what are they going by here? Ones. So down 15 over 1, 2, 3. Well, that's nice because that gives us a whole number slope of -5. And so that means our linear model to represent this situation would be -5x plus 95. Now, what are they even talking about here? They're talking about absences versus final grade. So let's see, the more absences you have, the lower your final grade goes. So predict the grade of a student who is absent for 7 days. For 7 days, it looks like they might have a final grade of 60%. So they would have a D- if they're absent for 7 days. What about a kid that's absent for 9 days? Oof, they're in trouble. So it looks like it would hit our trend line right there, which would be at about a 50% F. All right, so don't be absent. What if their final grade was a 40%? They might have been absent. Oh, it looks like it would hit way out here, maybe 11 days, maybe 12 days. So let's see what we would get if we plug that in. So if we plug in 40, 40 was the Y value, right? Because that's the percentage. So I'm going to plug in 40 for Y and see what I get. Equals -5x plus 95. We would subtract that 95 from both sides. And that would end up in a negative there. So what negative would that end up as? It'd be -55 would equal -5x. Hopefully you can see what I'm writing here. I'm going to divide both sides by -5, and we get +11. So what does that tell us? If their grade was at 40%, don't mind the noise, if their grade was at 40%, they must have been absent 11 days. So in order to do that, I just look for the labels right here. All right, let's go on to another one. Looking at this one, looks like this data is generally going up. That one's a little bit harder to tell. Looks like it hits the y-axis right there. So I want to use that, and then I'm going to angle it right about there. Looks like that would go through most of the points. So notice I do actually hit a couple of points. I've got 2 above and 2 below. And so that tells me that's a pretty good trend line. That looks like it's going in a positive direction. So the longer you study, the higher your grade is. Imagine that. Studying, your grade is going to go up. So let's write a linear model for this. Looks like it starts at, so the B would be at 20. And the M would be from there, from 20 to 70 goes up 50. And it went up 50 for an extra, let's see, half and 1.52, 2.5 hours of studying. And so in order to figure that one out, let's rewrite that as 100 over 5, which would reduce to 20. So for every hour of studying, your grade's going to go up an extra 20%. So as a linear model, that would be y equals 20x plus 20. So if you don't study at all, it's likely your grade is a 20% F. You spend 1 hour studying, now it's a 40%. You spend another hour of studying, now it's 60%. And that's studying for an exam. So let's study some more for our exams. Predict the grade of a student who studies for 3 hours. Looks like they might have an 80% based on the graph. If you study for 6 hours, we can't see that on there, but hours is X because of what the graph says. And so if I plug that in for X, Y would equal 20 times 6 plus, you'd at least get a 20% in a class for that. So 120 plus 20, so 140% in the class. Wow. If you studied for 6 hours for an exam. All right, let's go ahead and turn to this very last one. They have our trend lines done for us. Based on the data, how tall will a plant be for 4 months? Again, you look for where they're talking about months, so that's down here on the X. After 4 months, it looks like it hits right here. And so straight across from that would be about less than 50, more than 40, maybe about 45, what are they measuring that in? Inches. All right, so that's how we read trend lines. It's the same as all the other lines we've worked with, y equals mx plus b, using our y-intercept and the change from there. This week, we are going to be collecting some data and getting some practice at this, but do your best today, and you do still have homework on MyOpenMath. As always, visit me at the conference table if you have any questions. Have a great day. Yay, math!